Okay, so this is lesson 3.2. So hopefully you've already done these corresponding angle notes. And you have that they are on the same side of the transversal and either both above or both below their line. We're talking about these two lines. Okay, if the lines are parallel, this is the part that's new. So corresponding angles exist whether these lines are parallel or not. But once these lines become parallel, and this is how we mark them parallel, then corresponding angles are congruent. Now, unfortunately, this whole long sentence is its own theorem. The definition of corresponding angles doesn't make them congruent. They're only congruent if the lines are parallel. So when you write it in a proof and you say that these two angles are equal, you have to write this whole thing, this whole theorem. But luckily, I've got a way for you to abbreviate that. So you write it like this: if the lines are parallel, corresponding angles are congruent. So alternate interior angles are on different sides of the transversal and inside the two lines. And when the lines are parallel, alternate interior angles are also congruent. And here's how you would abbreviate that. Alternate exterior are on different sides of the transversal and outside, the two lines. And if the lines are parallel, alternate exterior angles are congruent. Oh, forgot a letter. You really do need to write this part, because if you don't, you will not know how to write it in a proof. Okay. And then these same side interior angles are the ones that are a little different. Remember, they're also sometimes called consecutive interior angles. They are on the same side of the transversal and inside the two lines. So if these lines are parallel, these are actually supplementary, which, if you'll remember, means they add to 180. So if you wrote that in a proof, it would look like this. Okay, so if we had this angle is 80 degrees, corresponding angles would be congruent. Then this one, alternate interior, would be congruent. Sorry, I forgot to mark these lines parallel. Then this one goes with this one to be alternate exterior angles being congruent. And don't forget, we also have vertical angles and linear pairs. So same side interior angles, like these two, are supplementary. So this would be 100. Same reason this would be 100. Also, these linear pairs should add to 180. Then we have corresponding, these two. Alternate exterior with these two. Also, these are corresponding, linear pairs, vertical angles. You've got tons of things going on here. But the whole thing is, if you've got two parallel lines in a transversal, you're only going to have two different angle measures. There will be 4 of one and 4 of the other. So this one right here and this one right here are what kind of angles? This tells us to name the relationship. These are alternate exterior angles. So this would also be 128. These are corresponding angles. Sorry, I forgot my angle sign, which would mean they're congruent. So that would be 83 degrees. These are same side interior. I don't know why I wrote that out. And so that means they add to 180. So you'd actually have to do 180 minus 57. $123. These are alternate interior angles, which means this would be 66. Okay. These are vertical angles, which just means that they're the same. And these are a linear pair, which means they add to 180. So this one is 50. You cannot forget these ones we've already learned because they show up all year long. All right, so these are same side interior angles. Those are the ones that add up to 180. So 55 plus 16x minus 3 should equal 180. So I would first combine my like terms that are on the same side. Then I would subtract the 52. And then 128 divided by 16 is 8. So x equals 8. Okay, these are alternate interior angles, so those are congruent. So we have 17x minus 5 equals 80. So you add the 5, get 17x equals 85. Divide by 17, excuse me, and you get x equals 5. All right, these are same side interior angles, so they add to 180. So 13x minus 5 plus 4x plus 15 equals 180. So combine your like terms. 13x and 4x make 17x. Negative 5 and positive 15 make plus 10. You'll subtract the 10 from both sides, get 17x equals 170, and then when you divide you get x equals 10. These are corresponding angles, so they are equal to each other. And if you want to pause this and try to solve them, you can. So then you add the 4, 2x equals 12, and x equals 6. All right. Oh, these are you try. So why don't you pause it and try, let's see, is it just these two? Yeah, just try these two and see what you get. Okay, so alternate interior angles equal each other. And same side interior angles add up to 180. Okay, so subtract the 5x, and then I'm going to add the 3. So then I'm left with 18 here, and 2x here, and I get x is 9. Then combine my like terms, 8x and 18x make 24x. 4 and negative 6 make minus 2. Add the 2, you get 24x equals 182. Oh no. Sorry, did that one too fast. 18 plus 8 is 26. So we're doing 26x divided by 182. Or 182 divided by 26. Sorry. 7. Okay, now we have the proof. And I used to do this proof where we had to find this angle, and so you had to use corresponding angles and then same side interior, but it seemed to throw some people off. So we're just going to do corresponding. Just remember that if you did same side interior, you would add them up to 180, and the reason would be this part right here. If lines are parallel, same side interior angles are supplementary. But let's do this one. So we have the measure of angle A, B, C, and we have this angle right here. Since they're corresponding, they should be equal to each other. And the reason you put is if lines are parallel, corresponding angles are congruent. Second step is always substitution. Then we would subtract the 4x, that's subtraction. Remember not to show your work. Don't do minus 4x, minus 4x. You don't do that in a proof. Also, I have a lot of people flip this around right here and do symmetric property. The only time you'd ever do symmetric is at the very end, and that's if it doesn't look like this and you need to flip it to make it look like this. But this is fine leaving it just like this. So we need to get what the measure of angle ABC is. So ABC in the picture is 4x plus 22. That's just given. So then we can plug in 22 for x. That's substitution. And then you actually solve it and get the measure of angle ABC equals 110. That is arithmetic because it's just math on one side. It is not multiplication. It is not addition. It's arithmetic. Remember, multiplication and addition imply that you do it to both sides, and this side has stayed the same. Remember, every step on a proof has to have an equal sign, so you should be able to draw through every equal sign. And that's the whole lesson.